Well, welcome back to the second half of the review for Chapter 6, and we're going to finish up number 33 here. We need to simplify some of these things inside the numerator, so we're still going to have the 3 and simplify this. This is going to be radical 8. We're going to kick the 4 out as a 2. Radical 18 gets simplified, and radical 144 is 12. Combine like terms. And we can combine these two radicals since they have the same index and the same radicands. And there we are. Next one, this is going to be the fourth root of 81. And you have to start thinking about maybe we can rewrite 81 as having a base of some number to the fourth power. So let's take a look at the fourth powers, or I should say what times itself 4 times is 81. Well, let's take a look at 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So we're going to kick this out as a 3. Next one, since we have the same base, we're going to add the exponents. 3 halves plus 1 half is going to be 4 halves, also known as 2, and that's 25. Next one, power to power, we multiply the exponents. Remember the exponent for this negative 8 is 1, so we're going to go ahead and distribute. Negative 8 to the 1/3, and 9 times 1/3 is 3. And we're going to be able to simplify this in radical form now, the negative 8 that is. And the cube root of negative 8 is going to be negative 2. Next one, we're going to have to go ahead and distribute the 18. 1/6 of negative 18 is negative 3. 1/3 times negative 18 is negative 1/6. Since these are negative exponents, we have to move everything down into the denominator. So we're going to have 1 over x to the 3rd, y to the 6th. Same thing here. I think that this got a little cut off, so I'm going to go ahead and try and move this here. There we go. And let's go ahead and distribute our 9 here. 1/3 of 9 is 3. And negative 2/3 of 9 is negative 6. If you're negative, you've got to move. So this is going to be x to the 3rd, y to the 6th. Next one, we're solving an equation. Divide both sides by 3 to isolate your radical. Square both sides to get rid of the radical. Solve for x. Subtract 6, divide by 2. Next one, isolate your exponential expression. Divide by 4. Now you're going to have to raise both sides to the inverse, or excuse me, the reciprocal of 2/3, which is 3 halves. And if you recall, when you're raising something to both sides with an even index, you have to use the plus or minus. So we're going to have to be careful with this one. We are raising both sides to an even index. On the left side, this will simplify to 1. And now let's write this in radical form. The square root of 9, our index is 2, all raised to the 3rd power. But remember, we're going to have a plus or minus here because we square rooted both sides of an equation. So we're going to have, in essence, 3x minus 3 equals 3 cubed, which is 27, and 3x minus 3, 9 cubed, or excuse me, 3 cubed negative is going to be negative 27. Add 3, divide by 3, and then add 3, divide by 3, and those are your two solutions. And again, if you need to check for extraneous solutions, you will obviously plug these back in to the calculator, or excuse me, into your function to see if you get a true statement or not. Next one, we're going to go ahead and have to isolate our radical, subtract 2 from both sides. I'm going to clear this up here. X plus 6 equals x plus 4. We're going to subtract 2 from both sides, and then we have to take the, we're going to have to square both sides to go ahead and get rid of that radical. So this is going to be x plus 6 equals x plus 4 times x plus 4. Let's go ahead and use the FOIL method. X squared minus 8x, sorry, plus 8x plus 16. That's going to equal x plus 6. Set this equal to 0. In other words, subtract x from both sides. Subtract 6 from both sides. So we've got a 0 here, so we're going to have x squared plus 7x plus 10. And our factored form for that is going to be 0 is going to equal x plus 5 and x plus 2. Therefore, our solutions are going to be x equaling negative 5 and negative 2. Remember to check for extraneous by plugging those back in for a true statement. Last one, number 51. We're going to go ahead and isolate one of our radicals. How about 2x plus 9? By adding radical x to both sides. Then we're going to have to square both sides to get rid of this radical. And we're going to have 2x plus 9 over here. And then we're going to have to write this out, radical x plus 3 times radical x plus 3. And we're going to have radical x times radical x, which is just x. 3 radical x and 3 radical x. And 3 times 3. Just like the last problem, we're going to have to set this equal to 0 by subtracting 2x from both sides. And we're going to have negative x here plus 6 radical x. And these 9s will cancel out. Then we're going to have to isolate our radical here. Add x to both sides. Then divide by 6. And we're going to have to square both sides. And we're going to have x times over 6 times x over 6 equals x. And we're going to have then x squared over 6 equals x. Multiply both sides by 6 to get that out from underneath the denominator, and then solve for 0. Factor out an x from both sides, or from these two terms, and then your solutions are going to be x equals 0 and or x equals 6. The other two, the last two, are going to be real quick ones that we can actually just go ahead and graph real quick. Hopefully real quick. Clear this up here to insert a little graph. So here are our handy dandy graphs. And what we're going to have to do is create a little t-chart for both these graphs. And since this is just a radical x, all we need to do is plug in some squares, perfect squares, and they'll be easy to simplify and be able to find our output for y. So let's plug in some perfect squares of 0, 1, 4, and 9. So let's plug these in. 0 times 5 is 0 plus 9. Plug in 1. 5 plus 9. Plug in 4. That's going to be 2 times 5 is 10 plus 9. Plug in 9. 3 times 5 is going to be 15 plus 9. And if you want to simply graph these, we're just going to go to 0, 9. 1, 14. I'm going to go ahead and move this. I think that would be a very good idea because we're going to kind of have to expand this a little bit. Oh, I was hoping that whole thing would move there. All right, I'll get a little sneaky. 114, about right here. 419, about right here. And 929, or 924, excuse me, about right here. And then we'd have some type of graph like this. So not only was this a stretch away from the x-axis, we also had a vertical shift up 9 units. Next one over here, probably just like the other one. We're going to have to go ahead and find perfect cubes for this one. Now remember, the perfect cubes are 0, 1, 8, 27, and that's going to get real big for our graphs. But remember, since it's cubed, we're also going to be able to work with -1 and -8. So what we want to do is to really focus on creating these 5 numbers underneath the radical. So let's find out what values we need to plug in for x to do that. Let's go ahead and make a 0. Well, I'm going to plug in -10 to make that happen. And that's going to spit out a 0 for us. So that one's done. Let's make a 1. How about -11? That's going to make us a -1. Well, we can still do that. We'll plug in -11, and that's going to spit out a -1. So that -1's done. Now let's work on a 1. How about a -9? That's going to spit out a 1. And let's try and make a -8. Let's see, that's probably going to be -18. And the cube root of -8 is -2. Now let's make an 8, so let's plug in a -2. Cube root of 8 is 2. Now let's plot these points. -10, 0. -11, -1. -9, 1. -18 and -2. So that's going to be somewhere over here. -18 down 2. And then -2, 2. So you can kind of see that we've got this kind of S-shaped graph that all cube roots have, and just give you a general idea. The thing I'm most concerned about is that you actually have these correct values into your t-chart. The matter of graphing them is almost secondary to having these values. There is your last part of your review, and we'll see you guys. Thank you very much.